Now we come to the part of these definitions that are adjectives. Orthogonal is an adjective, and there are actually 4 bullet points on the handout, and that's because we use this word orthogonal to describe a number of different nouns. The simplest one is the first one. If we're talking about 2 vectors, just 2 vectors, u and v, then orthogonal means that their inner product is 0. That's the definition. If we take the inner product and it's equal to 0, then those vectors are orthogonal. If someone has already told us that these vectors are orthogonal, that means that we already know their inner product is going to be 0. The next bullet point is, what if we have more than 2 vectors? If we have more than 2 vectors, we can still describe that set of more than 2 vectors as orthogonal. It just means that anytime we take a pair of them, that their inner product is 0. Now, a reading tip on this handout is, notice how it says I not equal to j, double right arrow, or I not equal to j implies that vi, vj is 0, like the inner product of the 2 of them is 0. That's because when we make this definition, we want to be very clear. If I does equal j, that means we're talking about an inner product with itself. We're not meaning to include that in our subject of what we're talking about. We're only talking about pairs of distinct. If we can pair any 2 distinct vectors together and their inner product is 0, then we call that collection of them orthogonal. The next bullet point is when we talk about 2 spaces, vector spaces. Remember, if we have a vector space, we're talking about an infinite number of vectors. And if we have 2 spaces, we can call 2 vector spaces orthogonal, and you might be able to guess what that one means. That just means that if we take any pair of vectors from those spaces, like a v and v, and a w and w, that inner product will give us 0. But notice that's a very strong statement, because that's for all little v and v and little w and w. That's a lot of vectors that would have to be orthogonal to each other in order to say that the entire spaces are orthogonal. The last bullet point is orthogonal complement. An orthogonal complement is, picture v being the larger space, and u is a subspace of v. We say the orthogonal complement of u would be everything in v, everything in the big space, such that all of the things in u are orthogonal to it. So it's everything orthogonal to u, but that's in the larger space v. So play this video over and over again, because it just takes some getting used to some of these definitions and reading and rereading that language.